Alright, this video is to explain another type of reaction, a redox reaction. So it's another one of the AP reactions we're responsible for. So if you look here, the first kind involves two metals. So how do we spot these? Well, the first type involves two metals. It's going to be two transitional metals is the key is what you look for. So you'll see two transitional metals. Notice I see nickel and I see copper. The easy 90% of the time, one is going to be in elemental form, which the piece of nickel is, or a solid, and the other one's going to be in a solution as an ion. So when I go to write this out, the first thing I do is, how do I show nickel as a solid? I just write Ni. Copper 2 as an ion, because the word solution, I write Cu. You know as soon as you spot two metals, they're transitional metals, it's a redox reaction. So basically what has to happen is the metals have to change oxidation numbers. One metal's charge is going to go up, the other metal's charge is going to go down. So nickel, I'm going to go from nickel to nickel 2 plus. That will be my oxidation. So they're going to basically switch places. The ion, copper 2, this will become copper, so that's supposed to be a solid, not a 5. Becomes copper as a solid. So that's how you have write out a simple redox reaction on the AP reaction section with two metals. One metal is going to be a solid, the other metal is going to be a ion, and what's going to happen is they're just going to switch charges. One goes up, the other one goes down. You have the oxidation part, you have the reduction part. Pretty easy, actually. Next type of reaction is two nonmetals. Pretty easy to spot. You should know what a nonmetal is. They're going to be halogens, actually. So one's going to be again in elemental form, should sound familiar. The other one's going to be in the form of an ion. They're just going to switch places. That's all that's going to happen. The oxidation numbers are going to change. One's going to be oxidized, one's going to be reduced. So if you look here, liquid bromine, which is the form that bromine normally takes elementally, is shown as Br2 because it's diatomic. Sodium iodide, we don't care about the sodium, but the iodide is a halogen, so it's going to be shown as I- because it's in solution. What's going to happen is they're going to switch places just like we did on the previous one. Bromine's going to become an ion, which is Br-. Iodine, which is ion, is going to be oxidized. It's going to go from -1 to 0. So I write as I2, diatomic. And then the last step is just balancing it. Put a 2 there and a 2 there, and there you go. Very simple reaction, very easy points, piece of cake. The last one is pretty easy too. First of all, you need to know the two famous reductions. One of them is taking, we talked about this in class, taking permanganate, going from MnO4 to Mn2 plus. Famous reduction. Happens very easily. You also have dichromate, Cr2O7, 2 minus goes to Cr3 plus. If they mention one of these in the problem, either dichromate or permanganate, you just write this from memory, and there's your reduction. All you need is an oxidation to go along with it. So whatever transitional metal they're going to mention, because they'll always use the transitional metal, you're going to increase its charge from the left side to the right side. That's your oxidation. That's where it comes from. The terminology they use is they use acidified in the problem. That's how you recognize it. In order to account for the acidification, you're just going to add an H plus to the left, and then to balance it out, you finish off with a water on the right. So let's take a look at this problem. Start out by noticing potassium permanganate, but especially the permanganate right here. So I write out MnO4 minus, and then that's going to equal Mn2 plus. Okay. The next thing I'm going to do is, there's my reduction. I need an oxidation. They gave me tin 2. So I'm going to write tin, which is going to be SN2 plus here. So write SN2 plus here. And on the other side, it's going to become SN4 plus, because those are the two charges of tin. There's my oxidation. Last thing I have to do is account for the acidification. So I'm going to add H plus on this side as a reactant, and that gets my acidified term done. And then I add water on the other side, H2O. And then from that point, all I have to do is balance it, actually. So I would have to put a 4 here, and 8 there to balance the hydrogens. Everything else should be balanced, and that's basically all you have to do. So let's take a look at this one. What do I notice? When I first look at this, I see a bar of strontium metal. I know I'm going to show that by just saying strontium is Sr plus. What else do they talk about? Solution to copper 2. Transitional metals. Actually, strontium is not a transitional metal, so I guess they don't always do that. Copper 2 plus. So I have one metal that's a solid, one metal that is a ion. They're going to switch places. What's going to happen? Copper is going to go from copper 2 plus to copper is a solid plus. Strontium is going to go Sr 2 plus. Done. Balanced. Perfect. Good to go. Next one. Acidified solution. They mentioned potassium permanganate. So the first thing I'm going to do is write MnO4 minus arrow Mn2 plus. It's an ugly 2, but there we go. That's the first step. There's my reduction. Well, my oxidation, I'm going to take iron. So I'm going to say iron 2 plus. The only other charge for iron is going to be iron 3 plus. Done. Have to take care of the acidified part. So I add H plus on this side. And then to cancel the H's on the other side, or to balance them actually, I add water on the other side. The last step is basically just to balance. We talked about that in the last slide. Just make sure they all balance. So balance the O's and the H's. Next one, chlorine gas. Chlorine gas is elemental in form. So I'm going to show chlorine gas is Cl2 plus potassium, which I don't really care about, but bromine. So this is a solution, so I'm going to write Br minus, arrow. They're going to switch spots. So Br is going to go to Br2 plus. Chlorine is going to go from elemental form to ion form, Cl minus. I put a 2 there, and I'm done, and I got my points. Those are redox reactions, AP style. They're very easy. They're very scoreable. All right. Have a good evening.